Hello, welcome to Accounting Hub. I'm Professor George Scarpin, and let's talk about chi-square test for independence, another business analytics class. So, what is the chi-square test for independence? When we test the independence of two categorical variables, for instance, preference for a certain range between men and women. So the two categorical variables are independent or they are dependent. So there is no difference between choices on a certain amount of rent between men and women, or there is. So let's go. The chi-square distribution depends on the number of degrees of freedom. We will work later on how to calculate it. And the chi-square point is the point under a chi-square distribution that gives right-hand tail area. So it is one tail only. There is difference or there is not. However, we need some cautions here. We expect some cell frequency, and if there is no more than 20% of cells with expected frequencies is smaller than 5, for instance, only 3 women choose brain 3. And if this is more than 20% of cells, then we need to consider to aggregate these numbers because they are very small, so it will not be a good number for the test. So we have 3 steps. Step 1, using a cross tabulation of the data, pivot table or count ifs. I prefer count ifs, but that is personal. We need to compute the expected frequency. Total of row times total of column divided by the grand total or the total number of observations. Step 2, we need to calculate the chi-square statistic. That is the sum of the square of the difference between observed frequency and expected frequency. Square it because we don't like working with negative numbers divided by expected frequency. We will go on that on Excel too. And then step 3, we need to calculate first the degree of freedom, and there is a very good Excel formula for that, and then the p-value. So okay, let's go to our Excel file. So let's assume that we have an automaker survey for marketing, and we have 3 brands, and we are testing the difference between men and woman, our gender. And we will use only 2 genders only to make it easier, not because there are only 2 genders, to make it clear. So we have 150 respondents. So I cross-tab the numbers. I use the count ifs. I prefer to use count ifs, but you can do using a pivot table. Why I prefer count ifs? Because if I change here, for instance, brand 2, it will automatically change all of my numbers. I don't need to refresh it on the pivot table. So, okay, these are my frequencies. And then, okay, what is the expected frequency? I copy and paste the formulas from the PowerPoint only to make it easier to not going backward and forward and backward. So that is why I copy on pictures. And by the way, this Excel file is on our video description and you can download it for free. So how do we do the expected frequency? The grand total of the row of our row here, 64, times, because we are talking about brand 1, times the total of the column J. So times 80. And it doesn't matter what we will take first. So total of females times total of brand 1 divided by the total number of observations. So we will do here, to copy and paste, you need to add dollar signs for some rows or columns. So I will do here, and you will have my formulas here with the dollar signs. Okay, now we have the expected frequency, and we will compare the actual frequency with the expected frequency. So these numbers should be the numbers if there were no difference at all, based on the number of genders and also the number of brains. Okay, how do we find the chi-square statistic? So let's delete this one. So equal actual minus expected, and we square it, divided by expected. So that is what we have, the 0.24. And this one you can copy and paste. You don't need any dollar sign. And then the chi-square test is, so if we come back here, the chi-square statistic is the sum of it. So it is the 6.57. And now if the chi-square critical value is lower than that, we reject. If it is higher, we accept. So let's see. So first, the degrees of freedom. Number of rows, 2 minus 1, 1, times number of columns, 3 minus 1, 2. Why do we need it? To find the chi-square critical value. So chi-square dot inv RT. And then probability, 0.05. So that is what we use the most. And then degree of freedom, the 2, 599, lower than the actual statistic. So we should reject it. This 0.037.5. So let's see how we do that. Chi-square test. Actual range, females and males. This is our actual range. Let's compare with the expected range. 0.37. So, or 38 if we round it. So we reject 80. However, if we go here, instead of brain 1, brain 2, 0.14, we accept it. Or we cannot reject it, depending on how stats guy you are. So that is why I prefer, by the way, the count if. You can create a lot of simulations and you can add data if you go to the count if, just like here, until the row 1000. And then you can add respondents. You don't need to redo the math again, just like on pivot tables. So guys, easy, huh? Very good for this kind of surveys. So a lot of categorical data. So if we come back on our PowerPoint, 2 categorical variables, brands and gender, for instance, students and pass-fail. So here we have this kind of scenario. So very good for qualitative studies as well. So guys, thank you so much. Questions or comments, just leave them here or email me. And have a very nice day and God bless you.